long division. In this part, we want to talk about the a polynomial divided by another polynomial. And this is used to find the factorization for a very high order polynomial. Okay, before that, let's review the division. And the general division we already know, which is if you have 233 divided by 3, so you have 7 here, right? Sorry. Two 33 divided by 3, so you have 7 here. This is 21. Take subtraction, you have 2, 3, and 7 again, and this is 21, and the remainder is 2, right? Everyone should be familiar with that. So what does this mean? This means 233 can be written as 3 times 77 plus 2. And here, this 2 is called the remainder, right? And this 233 is called the dividend. This is the dividend. This is the divisor. 3 is called the divisor. And this is the remainder. Okay, so it also can be written as this division can be viewed as 233 divided by 3 is equal to 77 plus 2 over 3, right? So now let's look at, so we can use the similar way to deal with the division between two polynomials. Between two polynomials. We use an example, okay? This is we want to know what is 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. Okay, we want to know what is this one. So we use the similar way. We still write down the symbol and yes. Okay, minus 4. This is x minus 2. So now let's look at here the two terms. So we start from the second term, right? We start from here. So this is we need to, the first one, we need to multiply which number becomes 6 times 6 x cubed. We need to multiply by 6x squared, right? So the first thing we need to make this one to be the same. So this is the 6x cubed minus 12x squared. Then we take the subtraction. Negative 19 minus, so this is minus this one is equal 0, right? The first term. Then negative 19x squared minus negative 12x squared. So it becomes plus 12 squared, right? So it's negative 7x squared. Then we move one term down. You have this one. So which number we need to multiply a number to make the first term to be negative 7x squared. Which number we multiply by negative 7x, right? Okay, negative 7x, so this is the negative 7x squared minus negative 7x times negative 2, it's plus 14x, right? So you have 2x minus 4. So how to make 2x? We needed to multiply by a positive 2. So this is the 2x minus 4, right? which is equal to 0. What does this mean? This means this one 6x cubed minus square plus 16x minus 4 is equal to x minus 2 times 6x squared minus 7x plus 2, right? So you can see if you write this one, we actually factorize it, and we reduce the order from third to this part, right? This is okay now. And we just needed to factorize this part using other methods, right? We can using other method to factorize this part. This is easy because this is x squared. So this is the long division will be used here. Okay, and so this is the this dividend can be written as this divisor times this number, and plus the remainder. Remainder is 0. Okay, so in other words, this one divided by this one is equal to 6x squared minus 7x plus 2. Okay, so now let's look at another example. Another example is we want to look at x squared plus 3x plus 5 divided by x plus 1. Okay, so we have two terms in the divisor. So we start from the second term, start from here. Right, 1, 2, right, we start from here. So we needed to multiply a number to make to be the first term to be the x squared. So we multiply by x, right? So it's x squared plus x times 1 equals x. So we take the subtraction. So this is 2x, right, plus 5. Okay, so then we needed to make 2x. So we plus 2, multiplied by 2, positive 2. So it would be 2x plus 2, right? So it's equal to 3. So then this is called, the remainder is 3. So what does this mean? This means x squared plus 3x plus 5 equals x plus 1 times x plus 2, then plus 3, right? Or you can review this division by x plus 3x, x squared plus 3x plus 5 divided by x plus 1 is equal to what? Equal to x plus 2. Then plus 3 is the remainder, 3 divided by x plus 1. Okay. So if you view this way, you can see actually we have a new fraction. This new fraction, the top order, the top degree is less than the bottom degree, right? Originally, the top degree is 2, and the bottom degree is 1, right? So here is 1. Here is 1. Here is 1, right? So after you divide, make this division, you see you have a new fraction, and the top degree is 0 and the bottom degree is 1, still 1. So we reduce the degree for the top, right? It will be much simpler fraction than we can deal with other knowledge. Okay, so now let's look at another example. We want to look at x cubed minus 1 divided by x minus 1. Okay, so the original, the previous two examples, we have each term, we have every term from the 3, from 2, and the 1, and to 0, right? We have every term. And here is from 2, then 1, and 0. This is x to the 0 term, right? But here we have x cubed, but we're missing, we have no x squared term. We have no x term. And then we have the x0 term, x to the 0 term, which is -1, right? Which is this part. This is x to 0. So when you do the long division, you need to fill in all the missing terms. What does this mean? You need to write x cubed minus 1 as x cubed plus 0x squared, 0 times x squared, plus 0 times x, then minus 1. We should have each term, okay? We should have all the term. There's no missing term. Then we can do the division, so it would be x cubed plus 0x squared plus 0x minus 1. Okay. Then divided by x minus 1. The same thing for this part. If this part missing some terms, you also need to fill in with 0 times that term. Okay, so now you can have, this is 2 terms, so you start from the second one. Okay, it would be x squared, right? To make x cubed, so it's x squared. So x cubed plus, minus x squared. Then we take the division, take the subtraction. So this 1, 0 minus negative 1 is the plus 1, right? So x squared plus 0 times x. So to make x squared, we need to multiply, to make x squared, we need to multiply by this x by x, right? So it's plus x. So this is x squared minus x. So we take the division, it would subtraction, so you have this 1 minus x, so it becomes positive x, then minus 1. So this is the same, so it's multiplied by 1. Okay, so we have x minus 1, which is equal to 0. Right. So this means this one is equal to x squared plus 1 times x plus 1, right? So in other words, x cubed minus 1 can be written as x minus 1 times x squared plus x plus 1. This is a very famous factorization. So now let's summarize it using the we're using which is called the division algorithm. So suppose the f of x and the dx are polynomials. Such that this dx is not a 0. We also suppose the degree of dx is less than or equal to the degree of f of x. Okay, so you can see from the previous examples, every term, so this one, the degree is bigger than this degree, right? And here this degree is 2, here is this degree is 1. So here the degree is 3 and this degree is 1, right? And here is, yeah. Then there exists unique polynomials Qx and Rx such that f of x divided by dx is equal to this Qx plus Rx over dx. Or you can write as f of x can be written as dx times qx plus rx. Rx here means, so for this expression, the Rx means remainder, right? The remainder. Dx is the divisor, and f of x is the dividend. Where, when you do the division, where this function, this Rx, the degree of Rx must be less than, there's not equal, okay, less than degree, the degree of the divisor dx. Okay, so here you can see this is Rx is 0, right? 0. Rx equals 0. So this degree is 0, but the original, the divisor, the degree is 1, right? And here is the Rx is 3, so degree is 0. And here is degree is 1. Here is 0, and here degree is 1, right? This is 1. So always less than, not equal to, never equal, okay? Another example, x cubed minus 2x squared minus 8 divided by x minus 3. So you can see that for the top, for the dividend, there is x term missing, right? The x term is missing. So we needed to add this x terms by multiply by with 0, right? So we plus 0 times x minus 8, right? So we didn't change the original one because plus 0 times x equals 0. It didn't change the original dividend, right? So it's divided by x minus 3. Okay, two terms in the divisor. Two terms, 1, 2, 2. So we start from here, 2, right? 1, 2, right? 2. Start from here. So this is the, we needed to make it to be x cubed, so we multiply by x squared. So x cubed minus 3x squared. Divide, take the subtraction, it becomes positive x squared plus 0x, right? We make x squared, so we need to times positive x. Positive x, so this is x squared minus 3x. So we take the subtraction, it becomes 3x minus 8. So we make 3x, we need to times a positive 3, so 3x minus 9. So it's equal to 1, right? So it means this one is equal to x squared plus x plus 3 plus 1 remainder over x minus 3. Or you can write this one as x cubed minus 2x squared minus 8 is equal to x minus 3 times x squared plus x plus 3, then plus 1, right? The remainder is 1. Okay, so now let's look at some theorem. The one theorem is called the remainder theorem. If the divisor can be written as x minus k, then f of x divided by this divisor, then this one is x minus k times qx, then plus the remainder. The remainder must be not, because the divisor is 1, the degree is 1, right? So the remainder should be a constant, right? Because the degree should be 0. 0 degree, that means there's no x term, so it must be a constant. So it must be written as this one, right? And a remark, we notice that f of k is equal to this r. Actually, we can estimate and we can calculate this r quickly. We just plug in k into the f, then you can get r. You don't need to take the division to find r anymore, right? Because this term, if you plug in k, x replace k, so this term would be 0, right? This term would be k minus k equals 0. Another theorem, which is called the factor theorem. Factor theorem, okay? It says x minus k is a factor of fx. It means, if and only if, it means it's equivalent to say that f of k is equal to 0, right? So in other words, from here, f of k, which is what? Which is the remainder. If the remainder equals 0, so it must be a factor, so that a factor of the original function. So you can factorize it, right?